Hi, this is Todd with Land of Math. If you're here, I assume it's because you're not sure the difference between a rational and irrational number. Well, you're in luck. This video will break it down and show you the difference between a rational and an irrational number. Coming up next on the Land of Math. In this video, we're going to look at rational versus irrational numbers. So rational numbers, we'll just kind of break it down kind of pyramid style for this one. So the first category is natural numbers, sometimes also known as counting numbers. And it's basically just 1, 2, 3, and it just kind of continues on forever. So that's considered a rational number. The next section of our little pyramid here is what we call whole numbers. And basically all we're doing in this situation is it's just the 0 plus all of our natural numbers. So it's just 0, 1, 2, 3, and so on forever. That gets us to our next category or next level here on the pyramid. So in this one is integers. So not only is this going to include the 0 and the 1, 2, 3, and so on positives, but it's also going to include all the negative numbers. So for example, in this one, I have -3, -2, -1 before you get to the 0, 1, 2, 3, but it would include like -20, -1 million, and so on. So that's our third level. This fourth level, we're just going to refer to it as rational numbers. All this obviously is rational numbers, but there's a whole bunch of stuff here that comes in this category or this part of our pyramid. First of all, any fraction is a rational number. So all the natural numbers, whole numbers, integers, they're all rational plus fractions. So any fraction, like 1/2, for example, in this case, 3/8, that would be rational. Let's say 49 over, let's say 50. So that would be rational. All mixed numbers, they're also rational. And by the way, all rational numbers you can write as a fraction. So if they're already in fraction, obviously they're going to be rational. So mixed numbers like 2.5, 1 7/8, or even like say 3 and 2/3. Those would all be rational numbers. Now with decimals, if a decimal is a terminating decimal, that means it's a decimal that comes to an end. So for example, the decimal 0.5, like if you look at the fraction 1/2 and write as a decimal, it would be 0.5. 1/4 we'd write as 0.25. It comes to an end. And 0.125, if it just ends there, those are all terminating decimals that just stop. Something that's also rational is repeating decimals. So these are a certain number or numbers that repeat over and over and over forever. So for example, if I had the fraction 1/3 and I wanted to write it as a decimal, it's 0.3, but it goes on forever. There's no end to it. If I had a 0.31 and the 3/1 repeated, that would be rational. If I had a 0.125 and the 125 kept repeating, that would be rational. And then one last thing that kind of makes up rational numbers is the perfect square. So if we're looking for the square root of a number like 100, or the square root of a number like 25, or if we're looking for the square root of a number like 64, these are all considered rational because when I find the square root of 100, it's 10, of 25, it's 5, and of 64, it's 8. So these, everything in this pyramid right here, this is all rational. Natural numbers, whole numbers, integers, fractions, terminating decimals, repeating decimals, and perfect squares. So you might be asking yourself, what's left? What could possibly be irrational? And there's a few different categories. So first of all, if we have any kind of a decimal that goes on forever and ever, and it does not terminate, and it does not repeat. So it doesn't repeat, and it doesn't terminate. If you get that situation there, that is a number that is not a rational number. That would be irrational. So for example, on this problem right here, let's say we have the decimal, and you can see it's 0.78156, and so on. When you're looking at these numbers, there's no pattern. We don't know what's the next number. After 4, what could it be? Okay, if it's 9, what would be next? It's a 2. We have no idea. Because there's no repeating pattern, it's going to be an irrational number. Another thing that's irrational, and this is probably the most famous of all irrational numbers, is pi. So it's a Greek letter And this letter, the number goes on forever. There is no ending. It doesn't repeat. There's no pattern. So because it goes on forever without a repeating pattern, this is also irrational. And then the final one is if we're finding the square root of a number that is not a perfect square. All those numbers are going to be irrational. So for example, the square root of 5 is 2.236, and it just goes on forever. The only reason it would stop on your calculator is you just run out of spaces, but there is no end. The same with 8. It's 2.82, and it just goes on forever. If we found the square root of 20, the square root of 20 is going to be 4.4, and it just continues on. There's no pattern. You don't know what the next number is. Because there's no pattern, it's an irrational number. So hopefully it was kind of helpful. If it was, please give it a thumbs up, and we would love it if you subscribe to the channel. That would be great. So until next time, we'll see you on the Land of Math.